Good evening, sir. Hello.
We can hear you, Sankar.
Yeah, very good evening. How are you all?
Good evening, sir. Yes, sir, we're fine, sir.
Okay. So in the previous class, we have just studied about the question paper.
Yes, sir.
Exactly. So today we are going to start the next chapter, that is the atomic structure and the chemical bonding, right?
Yes, sir.
So first of all, tell me that is this screen visible?
Yeah, sir. So I think we did so many mistakes in the corrections, sir. There is no way we got this mark.
Is now screen visible?
Yes, sir.
Okay. So we have to.
Sir, am I
Yes, tell me.
audible?
Yeah, you are audible.
Sir, are you like starting a new chapter today?
Yeah, exactly. We will start new chapter, that is atomic structure and chemical bonding. It's very important chapter.
Sir, can we ask us some questions from
Exactly.
the first 3 chapters, sir, instead of teaching a new chapter?
Yeah, you can ask questions, but we will also study this.
No, sir. I'm telling. Can you ask us few questions from first 3 chapters?
Sure. I will answer. Okay.
Exam preparation.
I will ask the questions I think I will give the last 20 minutes to that. First we will just study, right?
Yes, sir.
Okay. So our new chapter is atomic structure and chemical bonding. So that means we have to actually see here in this unit, we are going to study the structure of atom, and we will also discuss the various atomic models, that is the Thomson's model, Rutherford's model, Bohr's model, and we will also study about the chemical bonding. What is actually a chemical bond? So first of all, can you tell me that the concept of this actually the atom, what is actually atom? Can you define what is an atom?
So it is the smallest particle of matter, sir.
Yeah, which actually it is not the smallest. We are having more than
proton, electron, neutron.
Exactly, we are having electron, proton, neutron.
Everything.
They are much smaller. We are having the
Yes, sir.
okay. So I will just write it like this, that it is that smallest particle. So that it indicates that it is not the smallest only, because we are having more smaller particles like electron, proton, neutron. So I will write it here that smallest particle.
Sir, it is the small, sir, the smallest particle that contains charge, sir, which contains a valency.
Electron, proton, neutron also contains charge.
But electron, proton, neutrons, they don't contain valencies, right?
I will tell you, it is that smallest particle of matter which actually takes part in chemical reaction. So you will write that which takes part in chemical reactions. Which takes part in chemical reactions, right?
Sir, but electrons take part in redox reactions, right? So then isn't electron the smallest particle?
Not all reactions, like all in every reaction.
They are just your redox reactions, but actually the main reactions which we actually study in our daily life, they are those reactions in which atoms take part, not the electrons. So takes part in chemical reaction. So you will write like this, and you will remember this, that atom is that smallest particle of matter which takes part in chemical reactions and has no independent existence, and has no independent existence. So can you tell me what do you mean by this independent existence?
Sir, it can't
they
live
can't
independently.
exist independently. Like
Exactly. For example, if I
both
just
can only
talk of
exist.
hydrogen, if I just talk of hydrogen, how it exists? It exists as
H2.
H2, right?
H2.
Exactly.
Sir, can
Oxygen
you
exists.
wait for a second, sir? Sir, can you wait for a second? I'll rejoin. Don't teach anything,
Okay,
sir.
okay, sure, sure.
So finished
You can.
300 chapter. So I think they did some mistakes in corrections.
Where?
So like when you discuss the question paper, I marked the answers in the
Yes,
question
sir.
paper. Most of them were right, but still I got 25.5 only, sir.
Yes,
Lot of
sir.
So
things
They're
you
like,
didn't even teach, sir.
that
No,
means you
sir.
can you can recheck. You can just recheck that your answer booklet.
yes,
We have
sir.
to go
I'll
collect it.
recheck it, sir.
We have to
Exactly.
go collect it.
Rechecking will
Lot of things that you didn't even teach like came in the test.
I don't. No,
exactly.
sir.
So
No,
I'm just
the
saying that
sir
if you are
taught
having
sir taught everything there, but the thing is, I don't know. Like,
Crystallization, sir, didn't teach.
Hey, he thought.
bruh, he taught us,
Hey,
He taught what
I
crystallization
have taught
was.
already. See, crystallization, it is simply when we just make crystals from any impure substance. Just by actually what we do, we just cool
Sir,
the
you
hot
told
saturated.
crystallization is the process in which crystal is formed from a hot
Exactly,
saturated solution by
exactly,
cooling.
when cooled down.
exactly. That's right.
But then like there's various like shapes and all in it, sir.
Yeah, crystal
No,
is the
sir,
pure form.
there weren't any shapes in the question paper.
In the question
Yeah,
paper it wasn't there, but like in the book it's there.
This answer was in the
what types
question
of
Yeah,
paper.
but
shapes?
even mom told us to strike that off, right? Why are you worrying about it? Hello?
Yes, so what you want? Do you want to study that topic again, or shall we move
No,
to
sir. No,
this
sir.
No,
atomic?
sir, we can
No,
move.
sir. We can
No,
continue.
sir, no, sir.
Okay, okay. So then just focus on this, then I will let you know.
Yes.
Will answer your all questions. So I told that atom is that smallest particle of matter which takes part in chemical reaction and has no independent existence. But there are exceptions. There are exceptions. So can you tell me where is the exception? Except noble gases,
Noble
right? Do you
gases.
know?
Noble
Noble
gases.
ex-
gases. Yes, sir. Noble
ex-
gases.
Exactly. So noble gases can exist independently. Just we are having the helium, He. It
Neon,
exists as H.
fluorine,
Okay, neon we are having Ne. Argon we are having Ar. Krypton we are having xenon we are having radon we are having, and the last element of the periodic table, that is the oganesson, Og. So all these are noble gases, right? So you will simply remember that these noble gases, they can exist independently, but all other elements, they exist, they do not exist independently. For example, if I just talk of, let's say, chlorine exists as Cl2. If I just talk of fluorine, it exists as F2. If I just
two.
talk of any other, yeah, exactly. So all other,
Sulfur, you know,
and for
nothing.
example, if I just talk of carbon and hydrogen, they exist as CH4 methane. So that means you have to remember that this atom, it is that smallest particle of matter which takes part in chemical reactions. So you can see one of the example of chemical reaction. Just we are having this magnesium. It reacts with, let's say, oxygen, and what it will form?
Lithium oxide.
Magnesium oxide. Exactly.
Oxygen is
So now,
cannot.
yes, can you tell? Oh yeah, you can balance it right by writing twice here and twice here. It's now
So, but
balanced, right?
all metals also it's exceptional case, right? Sir? Or no?
Yes, actually, in case of metals, the atoms are existing in the form of metallic bond. There is actually a metallic bond between the two metal atoms, so they exist together there. So this is what is actually an atom. How we can define what is an atom? So I told that it is that smallest particle of matter which takes part in chemical reaction and has no independent existence except noble gases. So you have to remember that noble gases, they can exist as such. They can exist independently because they are stable. And we will
So what
also
is
see the reason.
XE? Sir, what is XE and OG, sir?
Okay,
Xenon
I will
and
write
then
it.
OG Shama.
It is the xenon. Xe is xenon element, and Og is the last element of the periodic table. It is known as oganesson.
for this, right?
Sir, what is that accent like thing above G, sir?
Cognizant, it
It's
is
just a
OG.
handwriting, bro.
Yeah,
Even noble gases he did like that.
it is just a noble gas, last element of the period. Do you know what is the atomic number of this oganesson, OG?
No, sir.
It is
Something
it is
like
100,
200, sir.
118. It is the last element of the
Yeah,
period.
yeah, yeah. Last.
Exactly, last element of the periodic table. So you just remember that this atom, except in these noble gases, all other atoms, they exist in the combined state, in the combined form. But other atoms, they just combine and they form the stable molecules. Now let's see the history of this, actually history of this atom, and then we will study the Dalton's atomic theory. That is very important. So shall I move to the next
The
page?
history of this thing is that, sir.
Have you written down this? I will
Yes,
tell you.
sir.
I will.
I think
Okay. So now, if I just talk of, we are having an Indian philosopher known as Maharishi Kanand. Okay, I will write it here. It was the Indian philosopher, namely Maharishi Kanand. Maharishi Kanand, he told that every matter is made up of very minute particles known as paramanu. So you will write it like this, that every matter. So I hope you remember what is matter. Anything which has mass and occupies space, right?
Yes,
Every
sir.
matter, yes, is made up of
his name is Maharishi.
Sir.
Maharishi Kanand, Kanad.
Kannada.
Kanad.
Kannada.
Yeah,
Last year we read it as Kannada.
Canada. No, you can
No,
just
sir.
call
His
it
name
as.
is Kannada, sir. Like
Not
Kanad.
Canada with a C, sir. K only, sir.
Okay. Let me write
Kannada.
as Canada.
Kannada.
So every matter is made up of very minute particles known as. So can you tell me what is the name given by this Maharishi Kanand? Every matter is made up of very minute tiny particles known as.
Sir, para something, sir.
Exactly, tiny particles known as paramanu. Okay, I will write it here.
Paraman.
Paramanu. So this was the term given by this Indian philosopher, that is Maharishi Kanand. Then came another Greek scientist, that is known as Democritus. So what Democritus told? Democritus told that every matter is made up of every matter is made up of small tiny particles known as atoms, is made up of small indivisible particles. Small indivisible, that means they cannot be further divided, right?
Sir, is
Indivisible.
atoms a Greek term?
Yes,
And it's Latin.
atom is actually derived from a Greek word, that is atomos.
Oh,
I will write it here. Okay, you have not to worry about this. So I told that according to Democritus, every matter is made up of small indivisible or uncuttable particles known as. So Democritus, he called these tiny particles as atoms. Now you will remember where from this term came. Actually, this atom, it is actually derived from Greek word. Greek word is atomos. So atomos means indivisible, uncuttable, right? So this is regarding that
atom,
who
no? Oh, atom.
atomos. Yes, atomos is actually the Greek word which means indivisible or uncuttable. So you have to remember that
Yes, sir.
this Maharishi Kanand, Maharishi told that matter is made up of very minute tiny particles known as paramanu, but according to the Democrats, every matter is made up of very small indivisible or uncuttable particles known as atoms. Now you have to remember
Yes.
that this atom it's actually coming from the Greek word, right?
Yes, sir.
Yes, sir. So can you flip your page, sir? It is like horizontal. Can you make it? Sorry, it is vertical. Can you make it horizontal, sir?
But
Sure, sure. So is it now fine?
Yes, sir.
Okay. So every matter is made up of small indivisible or uncuttable particles known as atoms. Or you can also remember here that this atom actually it is derived from this Greek word atomos, which means indivisible or uncuttable. So then actually we have to study, there was a theory given regarding the structure of atom, that is the Dalton's atomic theory. So let me show it on the
Sir,
next
so
page.
who found it first, sir? Did the Indian philosopher find it first or the Greek philosopher?
Yes.
Exactly, it is the Indian philosopher Maharishi Kanad, but he told these tiny particles as paramanos, and the atom term it was given by Democrats.
And also, he didn't
So
state that
he
it was indivisible and all.
yeah,
Yeah, exactly.
so Greek the Greek philosopher explained it detailedly, but the Indian philosopher was the first one to tell what it was. There was something like that.
Exactly. He told that there is something very small, tiny particles which were known as paramanos, but the actual atom term it was given by Democrats. So Democrats gave the term atom. Actually, it comes from the Greek word atomos, which means indivisible. Okay, then let's see the Dalton's atomic theory. Then
One second,
actually,
sir. 1 second, sir. 1 second, sir. I'll just
okay,
take
okay.
this.
Done, sir.
the me too.
1 second, sir. Almost done.
What were you doing
It
all the
is
while, da?
Asking a question.
Right when sir like finishes teaching one topic.
Hey, Bobby, why is your voice like that, huh?
Like what?
Now it's clear. Okay.
that.
Okay.
Yes, sir. He can continue.
So next we had studied in detail the Dalton's atomic theory. Dalton's atomic theory. So the first theory was given by Dalton regarding the atom.
Indivisible.
Have we studied this?
Yes. No, we didn't study, but
No, sir.
yeah,
Sir, we studied Dalton's atomic theory, but I
In
don't
like
know.
8th and 7th.
Exactly. Okay,
Yeah,
now, so tell me, this theory was given by John Dalton. So can you tell me in which year?
or
what should
18
I
or
say, sir?
19 something.
Yeah, it was 1803. Okay, so what this Dalton's atomic theory, it has, every theory has some main points or which what we call as postulates.
Atoms are indivisible. Atoms are subdivided into three parts.
Okay, so let us see the
They
various
are the smallest
postulates of
particle.
this theory. So the first postulate of this theory is that every matter is made up of very small tiny particles known as atoms, right? So this is the first postulate. Every matter is made up of every matter is made up of small indivisible tiny particles known as atoms, right? Known as atoms. So it was told by John Dalton. Then the next postulate, what he told, that was that atoms of same element they have similar properties. So I will write it here that
So what is
atoms of
KLAS?
it is known as, okay, it is known as, just I will write it here, it is known as so atoms of same element have similar properties. Atoms of same element have similar properties.
Which was later proven to be wrong.
Yes, exactly. Because in the modern atomic theory, we will see that we are having isotopes which have different properties.
Isotopes.
Yes, exactly. Okay, we will study isotopes, isobars, isotones ahead. But first, you just study this Dalton's atomic theory. So what he told, you have to remember. So atoms of same element have similar properties like shape, size, and mass, right?
Yes, sir.
Shape, size, and mass.
Sir, sir, like, why do we still study Dalton's atomic theory when it's wrong, sir?
Exactly. We have to actually go from the basics. So that is why we have to study each and everything. For example, if I will just move towards the modern atomic theory, then how we can properly understand that? Because when we first go through the Dalton's atomic theory, we will see that what Dalton told, then we will see its limitation, then we will move ahead so that we can properly understand each and every concept, so that we can see that what were the limitations in the Dalton's atomic theory and how it got modified in the modern atomic theory, and now what is actually atom, what is its exact structure. We will move ahead accordingly, because we are actually studying just like the history of this atom, right?
Yes, ma'am.
Okay.
Sorry, yes, sir.
Okay, so tell me here that, for example, if I'm just talking of, let's say, magnesium is my element. Okay, these are the atoms of
Sir,
magnesium. So that,
did it
yes,
state that atoms of same elements have similar properties or same properties?
it is
Similar.
one of the same thing. Whether you say same property or similar, it is one of the same thing. You can say the similar property or same properties. So tell me, for example, this is magnesium. These are the atoms of magnesium. So are they just looking similar? Yes, they are
Yes,
exactly.
sir.
Yeah. So that means they have same shape, they have same mass, they have same size. So this is what actually Dalton told here. Next postulate, let's see the next postulate here. Next postulate, he told that atoms of different elements have different properties, right? Atoms of different elements have different properties. So what will be the different properties then? Like what? Like shape, size, and mass.
So
Correct?
are we only studying 2 points in Dalton's atomic theory?
Three da.
Three, what? He's just writing the third one,
Okay,
right?
this one's
I'm
different.
writing
Okay,
this.
okay.
This is the third. So atoms of different elements have different. Sorry, I have to write here different properties, right? Okay, you will write it here that they have different properties. What properties? Like shape, size, and mass. Like shape, size, and mass. Got it? Okay, for example, this was your magnesium. Now, if I'm just taking, let's say, lithium. Okay, let's say I'm having, okay, lithium. So lithium atoms will be, let's say, bigger than this magnesium. So that means they are having different shape, size, and mass. So this is actually what here Dalton told, that every matter is made up of atoms. It was the first postulate. Second was that if we just have one element, that is same element, then its atoms will be having same properties, similar properties like shape, size, and mass. And but if we just take two different elements, then the atoms of two different elements, they will have different shape, size, and mass. So this is the third postulate. So
Except the
have you
last
put it
one,
up?
nothing is right, sir.
Yes.
Except the last one, nothing is right, sir.
First one is right. Oh wait,
First
first
one
one's
No,
is
also
it
not
is.
also
right.
not right,
First
because
one
he
is
First
told
one
also
is
wrong.
wrong.
indivisible. It is also wrong. It is actually indivisible. He is saying
Yes,
that it
sir.
is indivisible, but we know that atom can be divided. It is further made up of electron, proton, and
Yes,
neutron.
sir. So Democritus was also wrong.
Yeah, exactly. Democritus, he just gave the term atom, but then the theory was given by
He
Dalton
told
here.
it was indivisible, right? He
Yeah,
told
Never
it was
wrote
exactly.
it like
indivisible.
that.
Exactly. Atoms
Maybe
are
he wrote it
indivisible.
like that.
See, actually, see, it is the talk of what we are studying. It is just the history. It is the talk of 1803. So at that time, they just have this thinking that it is indivisible. But when experiments were carried out later on, then when the discovery of electron, proton, neutron took place, then it was clear that atom can be divided.
That's all and then
Okay. So shall I move to the next page?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, what was the fourth postulate?
Sir, what? Fourth what?
Fourth postulate was that
postulate.
atoms of
Fourth point.
fourth point. Okay, you are right. Atoms of SAM or different elements. Atoms of SAM or different elements combine to form compound atoms. So he at that time he told them as compound atom, but it is actually not the compound atom. It is actually the molecule, what we called it as today, right?
Yes,
Yes,
sir.
sir.
Can we
Yes.
write it as molecule in the bracket?
Yes, you can write in the bracket that now known as molecules. They are now known as
But in,
molecules, right?
so, but in exam you have to write it as compound atoms, right?
Yeah, you will prefer. See, Dalton told the compound atom, so you have to write the compound atom. But we know that now we.
So we could be wrong too, sir. In our future, they'll make fun of us. People like us.
Sir,
When we just have to study from book and write it in exam and we fail, you have to find something, bro.
Hey,
How can
that
you
time
expect him
under
to be right?
schools won't be there.
Hello,
They don't
sir.
have online. Please, sir, ask
yes, sir, it's lagging.
his screen is frozen. Sankal's face is
Sir's
so sad.
screen is lagging.
Sankal,
Even
no
Rick
one
Astley
did
is
good in this
struggling to
test.
do this.
It's either the marking or us.
I know that. Bro, when sir told all the correct answers, we all got it right and we all said it
Yeah,
correct. Like, I know, sir, how do we get things wrong?
I really got more in physics than I got in both chemistry and biology.
Got more in maths than chemistry. I was like,
I got
chemistry,
the
I'll
worst
get
in
38.
maths.
above.
Bro,
Tarun, I
biology,
don't know.
I can't even believe that.
It might either be
Yeah,
his luck
biology,
or his.
we are sure. Hey, even I got
Yeah.
19.5 in saying first rank. So Kongu
I know.
we got the same
Bro,
marks.
it either must be Tarun's luck or it must be his hard work or he just cheated and he's not telling.
Hard worker,
Tarun got
Taruna.
36.
Wait, they live on
Tarun
different
got 46.
universes.
Physics. First
Dude,
mark.
literally,
Congratulations,
I
Tarun.
had
You
been
deserve it.
who was a physics professor.
I think
Prof-
only physics his
professor,
mom wasn't nearby when he wrote it.
Hey,
Yes,
what
I know
you
that.
did? She monitors me.
Oh,
then.
no,
Please.
Bro, I got
Make-
suspicious the second you said that I can't come because my parents are not home.
Hey, he told me the guests were there.
Hey, he told me he had
Guests were
cold.
there in
Ah.
home there.
Hey,
Bruh,
what?
he told different reasons for each.
Hey, you guys are getting it in the wrong way. Look, my guess first reason my cousins came. Second, I was on cold. Friday
I
test
was on
alone, my
cold.
parents are out.
Yeah, so all of us were right, bruh.
Anyway, started preparing for your exam. Hey, let's stop it. It feels annoying for Tarun, but yeah, let's stop it. You finished. You started studying for your exams.
Yes, I did. I'm
Yeah.
I'm doing visiting computer science. Ma'am said everyone will easily get more than 80 marks, but I don't believe it.
Got 100 last time. Da.
Hey, there's no way you guys are passing art. Art is like the toughest.
No,
Bro,
not
art
the
is
thing
so
is, they
easy.
give us
No.
give us so much
My
marks,
exams,
Ra.
they're very strict. So, yes,
No,
sir,
they give
can
us
you hear
so
us,
much marks.
You
Sir,
just
are
Yes,
you
say
there, sir?
Can you
Yes,
hear
sir.
me?
Yes,
Okay.
sir.
Yes, sir.
Yes, Pongal, focus. Yes, sir. Can you hear us, sir?
Yes, I can hear you. So can you tell me that is screen visible?
Not
You
yet,
didn't share
sir.
anything. Oh, no,
Yes,
Not
sir,
yet,
it is
sir.
visible.
Now it is, sir. Now it is, sir.
Okay. So is it in the landscape mode?
Yes,
Yes,
sir.
sir.
Okay.
You guys
So I've,
finished history and physics, Ada?
Two. We have to study.
now tell me here that I told that according to the fourth postulate, atoms of SAM or different elements, they combine to form compound atoms, correct? Have you got this point?
Yes,
sir.
sir.
Okay, what is the next? Next is that Atoms combine in a simple whole number ratio to form compound atoms. Atoms combine in a simple whole number ratio, right?
Is that correct?
It is also having limitation. It is also not necessary that atoms will always combine in a simple ratio. So it is also having limitation. So atoms combine in a simple whole number ratio.
Is it always whole number, right, sir? It's always whole
No, no, it is not always whole number. But according to Dalton, he told that atoms combine in a simple whole number ratio.
We learned in balancing equations we get like 7/2 and all right there.
That's
Okay, see, actually here, for example, water. So what is the ratio in case of water? Can you tell me?
So 2:1.
so 1:2. 1:2.
2:1, da.
2:1.
2:1.
Hydrogen are
It's
2
2 is
and
to 1,
oxygen
2
is
is to
1.
1 there.
And in case of carbon dioxide, what is the ratio? It is 1:2, right?
1:2.
1:2.
1 is to 2, sir.
And in case of ammonia, what is the ratio?
1:3.
Oh, whole
1:3.
number ratio, sir.
It is not the mass ratio. It is simply the atomic ratio. It is the simply ratio of
Sir,
atoms.
it's not always true, right, sir? The atoms combine in a simple whole number ratio.
Exactly. It is not
Yeah,
always
it's
true.
Dalton,
That is
right?
why
Not
we have to
always.
study the modern atomic theory. That is why we have to study the modern atomic theory, right? I will
Brother,
tell you
if you
there.
said it was always true, then.
I'm smarter than
No,
the
no, it is
ones
not
who
always
invented atoms. I mean, discovered. Sorry.
So what's a simple like whole number ratio?
simple whole number ratio means just like this: 1:1, 1:2, 1:3.
Yes,
They
sir.
are
How
simple.
else can it be? How else can it be?
7:5.
Hey, Kongwell, in some balancing equations, you will get like 4 and it's very weird numbers.
CR207,
Basically. Not possible.
CR207.
Okay, you are
Weird
just
numbers, sir.
studying the limitation
Can you give an
along.
example, sir?
I will
Dichromate, sir. Dichromate.
see here. For example, okay, you are having the potassium dichromate. That is your
It is
K2Cr2O7,
not
right?
Or
possible.
like multiple elements. Multiple elements.
Similarly, you are having just like sucrose. Can you tell me the formula of sucrose? It is C12H22O11, right? So can you tell me, is it simple ratio here? It is 12 is to 22 is to 11. It is
Yes,
not a
sir.
simple ratio.
How
So
is it
that is
not a simple ratio? I
that is
don't know
why
It's
the
not
simple
simple,
ratio.
duh. It's
it
not
is
its
not
simplest
simple. So
form.
that is why I'm saying that it has limitation. But first, you have to see what actually Dalton told. So you have to remember.
So no, like how is it not a simple whole number ratio? What is a
Hey,
simple
just
whole
okay,
number
don't say
ratio?
anything.
Okay, I will tell you. Simple means when there is
Even,
one,
See,
two,
I have to tell.
3, 4. These are simple. Up to 5, these are simple. It should be 1 to 5.
Oh, okay.
Got it?
Okay.
Okay. Tell me the next postulate. Next is the sixth one. So next is that atom can neither be created nor be destroyed in any chemical reaction. Atom can
Oh, this is also
So
true.
what about
atom can neither be created nor be destroyed.
neutron collider? What is
Yes,
it?
actually atom can be destroyed. So that's why this is also not the correct. So but you have to remember the
How is
postulate.
it destroyed, sir?
In nuclear
Neutron collider
transmutation, we destroy it.
electron
so what
I will
is,
collider.
give you the example. In nuclear
sir, what is
transmutation,
C12H22O11 again?
it is known as sucrose, sugar. What
Sucrose.
we
Sugar.
sucrose. It is the sugar simply.
Yes, you
Sucrose sugar.
continue, sir.
Okay, now tell me that atom can either be created nor be destroyed according to Dalton, but we can destroy it. We will study it later in the
Yes,
limitations.
sir.
Okay, then what was the next postulate? Can you tell me? The atom is the smallest particle which takes part in chemical reaction.
It is, sir.
Atom is the smallest
Oh,
particle.
yeah, okay, yeah, I don't.
Yeah, it is
So it's the
according to
first
the.
one. Oh wait, this is a definition. This is the correct one.
That was
This is not
actually I
referred to
put the
definition.
definition of atom. This is the postulate of Dalton. So atom is the smallest particle of matter, yeah, which takes part in chemical reaction.
So it's correct.
Yeah. Yeah, it takes part in chemical reaction. It is correct. But it is not the only smallest because electron, proton, neutron, they are very much smaller to that of atom. But this is correct because it takes part in chemical reaction. Which takes part, T/P, it means which takes part in chemical reaction. Correct?
Yes, sir.
So these were the
Yes, sir.
postulates of this Dalton's atomic theory. I hope you can remember these. They are very easy to remember. Then
Sir,
let's
they will
see the
ask you to
limitations. So
write
have you
all
noted?
as 7, right, sir?
Sir,
Yeah,
how can he say, sir? I don't get it, sir. He just said that atoms
Mhm,
of same or different elements combine to form compound atoms, and
mhm.
now he says atoms can neither be created nor be destroyed. He just said that elements can be combined, can combine to form compound atom, and he's
Bruh,
like,
combination doesn't
See,
mean.
it's
Okay,
combination
see,
means
let's
it's
say
not
you have a
creating
piece of like
anything,
dough, okay? You put in
Okay,
another
I
dough,
know
that's
that.
combination.
I will tell
See.
you.
I know. See, I know it's a molecule, but he says it's a compound atom. How can he say atom can't be created when he just said compound atom can be
He
created?
didn't create it, Ra. He combined atoms
Okay,
to
okay,
get
no
two
problem.
atoms like that.
Why you just focus on? I will explain each and everything. If you have asked the question, then be patient. I will give you the answer. First, tell me, have you written down this? Shall I move to the next page?
Yes, sir.
I'm in the last
Okay,
line, sir. I'm in the last line.
you just write it. I will tell you the answer, exact answer.
I'm done, sir.
Okay,
I'm done.
Sankalp as well.
Sir,
okay.
what
Now,
is the word? What is the last sentence, sir? Which
But
after?
the atom is a
Atom is the
Limitation.
definition
smallest
of atom.
particle
atom is
which
the
takes
smallest
part in
particle
chemical
which takes
reaction.
part in chemical reaction. You have already noted that in the definition earlier. Okay, now
Yes,
see,
right.
your question is that atoms of same or different elements, when they combine, they form the compound atom. For example, this H and H combines and it forms H2. So this H2 is my compound atom, right? According to the Dalton.
Yes, sir. And he
Okay.
said atoms
Don't,
cannot be
don't I have
created.
understood your question, so be patient. I will tell you. Now, similarly, for example, this is my hydrogen atom. Let's say they combine with the oxygen atom, they form again the compound atom. Let's say it is H2O. This is the compound atom also. Now, your question is that you are saying that he told that atom can neither be created nor be destroyed. So you think that water has been created here. It is just when this hydrogen and oxygen it gets combined. You cannot creation means when you can create this water from nothing.
It
That
is
means
formed, not created.
exactly it is not created. When there is nothing and you are just producing water from that, so that means creation. You are creating from nothing. But here it is just the
So,
combination reaction. It is a combination reaction.
They're
It is
converting
not
it.
exactly. You are converting it from these atoms to this compound atom. So they are not contradictory to each other. So you have to remember this.
nothing
Got it?
plus nothing is
Yes, sir.
not
Okay.
two
So
nothing.
now tell me the limitation. So actually, what is the limitation of this Dalton's atomic theory?
Everything is wrong.
So many, except for his first and last one.
Exactly. So I hope
Last.
that you can write limitations yourself. So okay, I will just repeat and I hope that you can remember. So the first
Wait, wait,
limitation
wait.
he told that atom is indivisible, but we know that atom is no longer indivisible. Atom can be divided, right?
Sir, can we
Yes,
just
sir.
combine the limitations part with the modern atomic theory part? Because, like, that's basically the limitations.
Exactly. Okay. So do you want to study
Can,
the modern atomic theory without the limitations?
Yes, sir.
yes,
Yes,
sir.
sir.
Yeah,
Oh, okay. Let's see the modern atomic theory then. Modern atomic theory, it is also known as modified Dalton's atomic theory, right?
yes, sir.
Yes, sir.
So it also known as modified Dalton's atomic theory. So can you tell me who gave this theory?
Niels Bohr. Neil
Uh,
Bohr. Neil Bohr.
Was it only
What's
Neil Bohr, only one?
He like
sir, no,
concept.
sir. A lot of
Many people
sir,
did.
a lot of
Neil Bohr was
scientists, sir.
the
It's
like
like
primary one.
Exactly. There were various scientists. So one of them was the Neil Bohr, and other scientists were Thomson, J.J. Thomson.
sir,
Similarly,
Rutherford and Goldstein.
exactly, Goldstein was there. Okay.
Lord
But Niels Bohr is
Rutherford?
the important one.
Yeah, Chadwick was also there. Chadwick. Rutherford was
Chadwick,
also
Lord Rutherford.
exactly Rutherford. So these are the various scientists who just come together gave this modern atomic theory. So okay, tell me what is the first postulate of this?
atoms
Sir,
can be divided into
sir,
three parts.
atoms can be divided into three
Electrons,
subatomic
protons, and
particles
neutrons,
called protons,
and then that
electrons,
can
and
be
neutrons.
divided into quarks.
So it is just like this. It is just like this, that atom is no longer indivisible.
So when was this proposed?
Sir, it's not like it's no longer indivisible, sir. It was never divisible. It was never.
Sir, when was this proposed, sir?
It was proposed after 18. It is actually after 1830.
It was
Okay, sir.
proposed after Dalton died.
Exactly after Dalton's atomic theory, when there was the limitation. So atom is
No,
no
sir.
longer
What if
sir,
he was alive?
indivisible.
he would have regretted living there. That's why.
Atom is no longer indivisible. So that means that is simply atom can be divided, right?
Yes, sir.
Atom is okay. I will write like this. That is atom is divisible, right? Or you can also write that atom has complex structure. Do you know that atom has complex structure?
Yes, sir. It has something inside it.
Yes,
Meaning
exactly.
like
There are actually various small particles which are present inside this atom. So can you name few of them?
neutron,
Electron is there,
proton, electron,
proton is there,
orbit,
neutron is there. Similarly, quarks are
nucleus is
there,
there,
nucleus is there.
nucleus.
Okay, sorry, it is
What
quark.
blue gluons? What is that?
Mesons are there, positron is there. There are various small particles which we will study ahead.
What?
It
Positron.
is
What are positrons?
positron, yeah, they are also the particles. Positron, I will write it here, positron. Mesons are also there. They are very small tiny particles, but you have not to study these. You have to study electron, proton, and neutron. These three are very important.
So 1 second, I'm right finishing it.
Okay, just completed.
Are indivisible, right, sir? But
Yes, atom is no longer indivisible. That means atom can be divided.
that quarks.
The atoms were never indivisible, sir.
Yes, exactly. Atoms were never indivisible.
I asked quarks, sir. Quarks.
Quark is
What
actually proton and neutron. They are made up of quarks.
Those are indivisible, right, sir?
Yes, that means yeah, they are also indivisible. So completed.
No, sir.
Oh wait. That's finished.
Okay.
Yes, sir. Done.
1 second, sir. 1 second, sir.
Sir,
So once
no
can
need,
you
sir.
go
He
back,
finished.
sir?
Okay, I will go back.
Atoms are indivisible.
I was in the
Divisible.
last line.
You
Electron,
learn to
proton,
write
neutron,
faster.
quarks. You don't know that.
Right when like sir starts teaching. Like
So what about gluons, sir? Gluons. Like it's
Yes,
gluons. It's also a
exactly. That
particle.
also exactly. They are also inside the atom. There are various particles like there is positive meson, negative meson, neutral meson.
What is that?
Similarly,
Gluon.
these are there are gluons exactly. But we have not to go through that. We have to just study the discovery of electron, proton, and neutron.
Yes, sir. Done, sir.
Okay, so tell me the next postulate. What was the next postulate of this modern atomic theory? What he told that atoms of same element have similar properties. So he, according to modern
No
atom,
isotopes, isotones.
So there are isotopes. Sir.
so atoms of
Isobars.
same element can have different
Do not
atomic mass,
in size, shape, and
can have different atomic mass. And what actually they are known as, they are simply known as isotones, right? Isotopes. Sorry, isotopes. So what are isotopes? Can you define what are isotopes? We have to
so
study
an
them in
atomic
detail.
number is same, and mass number is
So
Exactly. So for
Yes.
example, hydrogen, we are having 1H1, this is the protium. 1H2, it is known as deuterium, and
Sir, the
1H3, it is known as.
isotopes of carbon is carbon, coal, coke, and diamond, sir.
Exactly. Carbon, we are having 612,
Diamond
6.
is not a isotope.
Diamond is
It
the
is an
allotropic
isotope.
form.
Yeah, it's
Okay.
allotropy. It's not a isotope.
The allotropic form,
Sir,
that is
but
not the.
it is still a form of carbon, right, sir?
Yeah,
Yeah, that is the
Yeah,
form of carbon. That is
carbon
why
is
I told
great.
that is the
it's
allotropic
not
form.
an
Allotropic.
isotope.
Then what's the difference between isotope and an allotrope?
Exactly. I will tell you. Allotrope is simply, it is okay. I will write it here. Allotrope. Allotrope means they are simply different forms of same element. Different forms of same element. When we have element same, but it exists in different forms, so that means they are
Amorphous form,
allotropes.
aqueous
For
form.
example, for example,
That
diamond.
means,
Diamond is.
so that means diamond is basically carbon, but it is put in more
In hard
pressure and heat. That's why it forms diamond.
crystal.
Actually, they
Crystal.
differ in their structure always. Allotropes, they differ in their structure. For example, diamond, it is having tetrahedral structure. That means each carbon it is attached to four other carbon atoms. But in case of graphite, each carbon is attached with only three other carbon atoms. So this is the difference in the structure. So that means allotropes, they differ in their structure. You have to remember this. Got it?
So we have it this year. Is this in the syllabus or?
Yeah, it may be ahead. We will study at
Sir,
that
I
time.
don't get it, sir. I don't get it, sir.
Okay, I will
They
explain. I'm just
okay,
saying
sir.
that
Not even
graphite
that.
and diamond, they have different structure. They are the different forms of the same element. For example, diamond, in case of diamond, each carbon it is attached with four other carbon atoms. But here you can see in case of graphite, this, let me take this one carbon, so it is attached with three other carbon atoms only. But here it is attached to four carbon atoms, so they differ in their structure. For example, this structure is your tetrahedral. It is a 3D structure. Actually, diamond is having 3D structure, but graphite is having planar structure, linear.
Sir, in the book only like three atomic theories of Dalton's and modern atomic theory are given, sir. But you wrote like six.
Which six?
So we wrote six postulates of Dalton's atomic theory, but in book
Hmm.
there's only three.
No
Those are
problem. But
submissions.
actually, see, you are on. Actually, when you move into the higher classes, you study all these other postulates also.
Yes, sir.
Actually, text is always considered. When you just study the reference book, you will get all other postulates also.
Even the
This chapter
angles
is
matter,
usually
right, sir?
easy.
Yeah, this chapter
Yes.
is very important and is also easy. Yeah.
The angles also matter, right, sir? Like in graphite, the angles is different, but
No,
in
angles, I
diamond,
don't
the
think it
angles
matters.
Exactly, exactly.
They
In
won't
case of
ask
diamond, angle is 109 degree 5 minutes, and in case of
oh,
this,
it's like
it's
100,
120.
so.
120.
Angle is also different here. So you have to simply remember that allotropes, they are the different forms of the same element. Allotropes have different structure, but in case of isotopes, they have same atomic
Sir,
number.
so
And
diamonds have
But same
same angle
structure.
as same
yes,
structure as ammonia.
no, no, no. Diamond has same structure as your methane is having. Tetrahedral. Methane is how having structure tetrahedral. That is just like this. Carbon is in the
Yes,
center, and
yes, yes, sir.
Then had connected to four.
Sir, even ammonia, sir. You told even ammonia has 109 degrees 5 minutes.
But it has like four things outside,
there are
No, three.
four
It also
atoms.
has
There should be
four.
four atoms attached. In case of ammonia, there are only three atoms, three hydrogen atoms.
Come on, Sankalp.
Okay.
It
Ammonium
is
is
just
only four.
it is just like this. Ammonia is having this shape. I will write it here. In this chemical
But
bonding, you will also see the shapes of molecules.
but
So
in
here it's
ammonium, this pattern is not
angle is
followed.
107 degree. Angle is 107 degree.
Okay.
Here it is 109 degree. Got it? Okay.
Yes, sir.
They can have different atomic mass. just in case of isotopes. For example, what are the three isotopes of hydrogen? So can you name these three isotopes?
Forgot, sir.
One H,
Sir, we
one
forgot.
H1 is known as, it's known as
We
protium,
forgot,
right?
sir.
Oh, his name,
Protium. And one H2 is, it is known as,
Electrium.
it is known as deuterium. Deuterium.
Oh, nice.
And this one H3, it is known as tritium. Or some also read it as tritium, but better is to call it as tritium. Have you noted down these?
Sir, hydrogen
Second.
has more than three isotopes, sir.
Hydrogen has only three main isotopes, that is your protium, deuterium, and tritium. Only three.
Yes, sir.
Told you
Finish,
more
sir.
than three. Only three.
Done,
Only
sir.
three are. Okay. So shall I
Done,
move to the
sir.
next?
Yes, sir.
Yes, sir.
Tell me now the
Yes,
third
sir.
postulate. What was third? According to Dalton's theory, atoms of different elements have different properties. But according to modern atomic theory, atoms of different elements can have same atomic mass, right?
Yes, sir.
Isotone.
They are known as isobars. Atoms of different elements
Isobars,
can have same atomic mass, right?
Yes, sir.
Yes, sir.
And they are known as isobars. So can you give me the example of isobars?
We never learned isobars.
Okay, we will study. So actually isobars, they are atoms of different elements. For example, argon is one of the
Sir,
element,
is it
calcium.
is it isobars or is it isobars? BASS or BARS?
It
Bars,
is
yeah.
BARS.
We
Bars.
studied this.
It is BARS,
No, we
bar.
didn't study this. We didn't
We
study
did
this.
We
study
did
this.
study this.
No problem.
did,
We
sir.
have to study in this unit. Why you are worried about? We have to study ahead in detail. First, we are just studying the postulates. Then we have to study separately these isotopes, isobars, isotones. We will study them in detail. Not to worry. So now
Well,
tell
I
me
don't
here.
remember. Are you happy?
Okay, now tell me, argon, its mass is here 40, and calcium is also having the mass 40. So what are these? These are your isobars. Got it?
Yes, sir.
Yes, sir.
Okay, can you tell me, are they isobars? For example, if I'm just talking of this nitrogen 7, mass is 14, and if I just write carbon 6 and 14, so are they also isobars?
Sure. Yes, sir.
Yes, they are also
Uh,
isobars because these are atoms of different elements. This is your carbon and this is your nitrogen, and they have same mass, atomic mass. So they are also isobars. So that means you will simply remember that atoms of different elements, they can have same mass, atomic mass. Okay, tell me the fourth postulate.
Even,
So
sir,
Mhm.
even tritium and lithium are isobars, right, sir?
No, lithium is having mass
Sir,
7. Lithium is having mass 7, and tritium, that is having mass 3. So how can they be isobars? They are not isobars.
oh, sorry. Sorry, that's oh, I got
Ex-
confused, sir. Sorry.
Exactly, exactly. Okay, now
Fourth
let's.
one, I think,
Sir,
atoms
they
combined
are the
in
third
a
element, sir.
complex
I thought
whole
we
number
had.
ratio.
So what Dalton told that whenever atoms combine, they always combine in a simple whole number ratio. So, but according to the modern atomic theory, whenever
Complex,
atoms
not
combine,
whole number.
they, yes, it is always not the whole number ratio. So you will just write like this, that atoms combine form molecules. So atoms combine to form molecules. Now we know that these compound atoms are actually our molecules. So atoms combine to form molecules in which a ratio is fixed and integral, but not always simple. So have you got this point?
yes, sir.
but not always simple. So that means the ratio, it is not necessary that ratio will always be simple. For example, just I have already given you the example, that is the sucrose C12
The
Rose.
sugar.
as 22O11. Yeah, it is the your sugar which you are just taking in your homes. So here the ratio is 12 is to 22 is to 11. You cannot simplify this. So that means this is not a simple ratio. So have you noted down this?
Yes, sir.
Yes, sir. I finished. And the
We're done, sir.
Okay, so tell me the next postulate then. Now
We
the
only
one
have
of the
3 in our
postulate,
book,
one of
sir.
the postulate was just taken as the same, that is atoms. Atoms are the smallest particles which take part in chemical reaction. It was just kept as there. So atoms are the smallest particles which take part in chemical reaction.
So, since when the atoms can neither be created nor destroyed, but it can not be created, but it can be destroyed.
So you will write
Is that
that
how it?
atoms are the smallest particles which take part in chemical reaction. Okay, next was that Dalton told that atom can neither be created nor be destroyed, but according to the modern atomic theory, atom can be destroyed. So
But cannot be created.
yes, atom can be destroyed.
So destroyed means where will it go? So
Yes,
where will it go? So destroying.
I will just give you the example that where
Nuclear
this
fission and fusion. Will we
example, for
Huh?
convert
example,
it to energy?
Will like no clip into the bathroom?
in nuclear reactions we can destroy this atom. For example, I will just give the example. For example, this is my beryllium. What is the atomic number of beryllium? It is 4, right? What is the mass? It is 9.
4, sir.
Okay, now
9, sir.
when it is actually reacted with the helium nucleus, helium is having atomic number 2, mass number is 4. Now what we get here? We get here carbon, that's atomic number 6 and 12. And we also get a tiny particle, that's actually the neutron, which we will study ahead in the discovery of neutron. So this is my neutron, n01, it is the neutron. Okay, now tell me here that firstly we were having this beryllium, but when this reaction takes place, it got converted to carbon. So that means we can convert one atom into another, we can destroy it, we can form a new element. So is it now clear? So that means we can destroy atom, and we have just here got new another particle, that is your neutron, right?
Yes, sir.
Now can you tell
Sir,
me
if
how
I'm
to?
not wrong,
Okay, tell.
so like, does it get converted into some sort of an energy and just get
Yes, sir.
released?
That's what I asked.
Exactly, whenever there is any nuclear reaction, there is also some energy is also released. Energy, you can write
No,
plus
sir.
E is.
What will happen to
So
the
the excess
destroyed?
mass is converted into energy.
Exactly, we will study it ahead. That is actually the Einstein's equation, that is E is equal to mc square. So that means mass gets converted into energy, and similarly energy gets converted into mass, right?
Yes, sir.
Okay, so I will write it here that
Sir, what is TPL, sir? What is TPL?
what?
Not
TPL.
TLC. It's like take part. Take part.
TLP.
Take part.
It is takes part. It takes T/P. It means takes part. T/P. It means takes part. Okay, now tell me that here what you have got. We have got that atom can be destroyed. We can just convert one atom into another atom, right? Is it clear?
Yes, sir.
So this was the modern atomic theory and the postulates of this. I hope that now you can ask the question. If you have any doubt, any question, you can tell me.
What will happen to the destroyed molecules or atoms? Sir?
Bro,
Yes.
it will be converted into energy. He just said, right?
Yes, here it got destroyed. We have also got the energy, we have got the neutron, we have got another element, carbon, from this beryllium. So that means it is the destruction here. That means atom has been destroyed.
What is Sir, what
Sir,
is
carbon is created,
okay.
right, sir?
Yes.
Sir, that means from beryllium and helium, carbon was created, right, sir?
Yes, we can discover the new elements. Carbon has been formed by reacting beryllium with the nucleus of helium. Helium is
Sir,
here the
but
nucleus.
atoms cannot be created, right?
Stone was
Yes.
created.
Creating is, he said it's from thin air, right?
Creation, I
Like you
told
just
just
can't
for
Not the
example.
thin air.
you just can't get it. I mean, there is nothing, and when you want something, it can't be done, right? So it's like
Exactly,
that.
exactly. We cannot create. I told that when there is nothing and you just
It
make
is
some element.
formed. See, carbon is formed.
Exactly, it is formed here.
From
Carbon is
what,
formed.
sir?
Sir,
Hey,
I didn't even
carbon
ask
is
it, sir. I
from.
just asked if
See, da.
Sankalp, I
See,
didn't ask you.
I'm
No,
not
I don't
talking
want
to
to hear you.
you.
Uncle,
I'm not talking to you, da Konguvel.
hey, even me, da. I'm asking sir. Da.
If you have
Yeah,
any
sir.
question, you can ask me. You don't just discuss with each other, right?
Yes, sir. That's what I'm
Okay,
also
and
telling. I'm just
okay now.
asking. So
Mhm.
atoms cannot be created, right? They cannot
Yes,
be created.
they cannot be
Okay, sir.
destroyed.
That's all I asked.
Yeah.
So then where does carbon come from, sir?
Where from this carbon came?
It's
Okay, it is
formed.
simple. Okay. This was my question to you that how to balance this equation. Then I will tell you where from this carbon actually comes. Can you balance
Okay,
this
I
equation?
wanna.
How to balance it?
Sir,
Can
add
can
carbon, sir.
anybody tell me how to balance this equation? Because this is a nuclear
Sir,
reaction. It is not an.
Sir,
sir, we have to add carbon to the left hand
No,
side
no,
and
no.
add
You,
beryllium and
sir, no.
helium
So one
to the
second.
right hand.
you cannot add carbon to the reactant side and the beryllium on the product side.
Oh, okay. Sir,
See, see.
it's because I know it, sir, because the mass values and the atomic values, when you add up, you'll get carbon and one neutron. One neutron.
Exactly. See how to balance this. See, tell me what is the atomic number here? It is the 4, right? And what is here atomic number? It is
Yes,
2.
sir.
4 plus 2, that is how much? That is 6.
6.
And here you can also
Sir,
do the
but
same.
where did that one
6.
neutron come from, sir? Where did that one
Sankalp,
neutron
please,
atom?
da. Let him
You just
finish first.
why you are so much irritating me? I just told that we have to study ahead the discovery of neutron. I will tell that how this neutron actually gets discovered, how this proton got discovered. First, remember here that how to balance this. What I am saying, you just focus on that. So it is now 6 here, and it is here 0. So 6 plus 0, that is 6. So that is why 6 here and 6 also here. So it is balanced. Now, same is the case in case of mass. 9 is here the mass, and here it is the 4. So 9 plus 4 is how much? 13.
Well, I mean,
And similarly,
Yes,
it is
sir.
here 12 plus 1. So that's also your 13.
oh,
So this is how to balance the nuclear reactions. You will not add any carbon or beryllium either on the reactant side or product side. You have to balance as it is because this is a nuclear reaction. You cannot add anything. Got
I
it?
think like
So have you got it? So that is why this is actually one of the
Yes, sir.
reaction with which we discovered the neutron, which we will study ahead. But first you remember that atom can be destroyed. This is one of the postulate of this modern atomic theory. So any question in today's class?
Sir,
No,
I
sir.
have doubts, sir.
Okay, so let's then close today's session here.
Excuse
Have
me,
a nice
sir.
day ahead. Yes?
Excuse me, sir. Sir, where did you get that extra electron from, sir?
This is
Which extra
energy.
electron? It is
Sir, you
energy.
said
that's
n plus.
E. That's
It is
E.
ener-
It's not electron. That's E.
Okay,
it
then.
is energy.
Yes, sir.
Okay, so shall we stop today's class here?
Yes, sir.
Yes, sir.
Okay, have a nice day ahead.
Yes, sir.
Sir,
Thank you, sir.
thank you, sir. Bye, sir.
Yeah.
Sir, is there any symbol for energy?
No, there isn't any. Yeah, you can represent energy by h nu also. We will study that in the Planck's quantum theory, but you have not study here in the lower class. In the higher classes, you study the Planck's quantum theory. We can represent energy by h nu. There is some h nu.
Yes, sir.
Okay.
Thank you.
Okay. Okay. Bye. Have a nice day ahead.